Alright, welcome. Let's work Algebra 2 Quiz 8.1. So we're going to write the number in simplified radical form. The first one is the square root of negative 48, so we're going to rewrite that as think about the factors of 48 that might be a square number. 16 divides 48, and 16 is a square number. So we've got the square root of 16. 16 times 3 is 48, but I've also got that negativity there. So I'm going to say that's equal to 4 square root of 3i. The second one is the square root of 4/3. So that's where we're going to say, all right, well, that's the square root of 4 over the square root of 3. And that's 2 over the square root of 3. That's halfway there, right? We got to simplify this by rationalizing the denominator as well. Simplified radical form is no unreduced radicals and no radicals in the denominator. So we just got to multiply this by square root of 3 over the square root of 3. And remember that root 3 times root 3 is just going to be 3. Let's say that's 2 root 3 over 3. That's our answer. That's simplified radical form. Now we're going to simplify the expressions assuming the variables are positive, and we're going to rationalize any denominator we might encounter. All right, so let's see, the cube root of negative 8, I'm just going to do these separately. Cube root of negative 8 is going to be negative 2. And then the cube root of negative 9, or x to the negative 9, I'm going to divide that power by 3. That's what the cube root does. It's the 1/3 power. So I'm going to say that's x to the negative 3. And, I didn't say that we needed to have positive exponents. I think it might be good for us to remind ourselves that we know that negative 2x to the negative 3 is the same number as negative 2 divided by x to the 3. Okay, that the negative on that exponent only makes it a fraction. It doesn't have anything to do with it being like positive or negative. So, all right, the next one's root 24 x to the 6 y to the 9. So I'm just going to kind of work these separately. Root 24, root x to the 6, root y to the 9. Okay, now, as far as, what does it look like to simplify the square root of y to the 9? I'm not totally sure. In my class, I think, I've told people to just say that's y to the 9 halves power. But that's good. I want you to be fluent in the, relationship between radical form and fraction exponents. That's what I really want. But, some other people might say that's y to the 8th times y and call that y to the 4 times root y instead of that, but it's all the same thing. Okay, I would hope that you could recognize that y to the 4 times root y would be y to the 9 halves. Maybe you're not quite there yet, but hopefully you're getting there soon. Okay, so square root of x to the 6. The square root is the half power, so it just divides the power in 2, so it'll be x to the 3. And then square root of 24. What is a number that divides 24 that's a perfect square? And I'm seeing 4, so I'm going to do square root of 4 times square root of 6. And square root of 4 is something that we know, so I've got 2 root 6 x to the 3 y to the 9 halves. All right, number 5. I think, since these are both square roots, I'm not really looking forward to working with square root of 12 and square root of 3. Maybe I'll just combine them first before taking the square root and see what happens. Okay, what if I did 12 times 3 times x to the 5 times x to the 3? And it's like, okay, yes, this is going to work out much better. So I'm going to say that's the square root of 36 times x to the 5 plus 3 would be 8 total powers of x. Then the square root of 36 is 6, and the square root of x to the 8 is going to be x to the 4, right? Half the power. So I've got 6x to the 4th. Okay, and then this next one, I was hopeful it would go the same way, but it does not appear that's how it's going to go. I'm going to take the square root of the top. The square root of 4 is 2. The square root of x to the 4 is x squared, at least if x is positive, but it told us we could assume that. And then we're dividing by the square root of 5. We're going to need to rationalize the denominator, so we're going to multiply by root 5 over root 5. And then I'm going to get 2 square root of 5x squared divided by root 5 times root 5, that's just 5. Okay, next, we're going to write the expression as a rational power of 60. That means 60 is the base of the exponent, and the exponent is a rational number, or a fraction. This one's going to be 60 to the 4/3. What I've been saying is, just remember the index of the radical is the denominator of the fraction, okay, because the square root is the 1/2 power. So over here, I'm going to have 60 to the 9/2. Halves because the square root, the regular square root, that's 1/2 power. It's like the second root right there. Okay, 60 square root of 60. Okay, well that'll be 60 to the 1 times 60 to the 1/2 power. I could add those together, and that would be 60 to the 3/2 power. That was a little tricky. It wasn't just written like the other two. But, you know, we need to be able to recognize that 60 root 60 is the same as 60 to the 1.5 power. All right, the last two are just, evaluate the expression. So figure out what this number equals. So what we're going to do is we're going to start with the denominator of the fraction. Okay, so the second root, that's the square root of 4, and then we're going to cube that. Okay, start with that. So the square root of 4, that's 2 to the 3rd, and that's going to be 8. Okay, with that one, this one we're going to do the same thing. We're going to start with that third denominator, negative 2/3. We need the third root. So I'm going to take the cube root of 27. Oops, forgot to put the top on that. That cube root of 27, and then we're going to take that to the negative second power. Okay, and I'll deal with the negative last of all. So I'm going to say the cube root of 27, that's 3. Okay. So that's like 3 squared to the negative 1 power, or you could say 3 to the negative 2 is 1 over 3 to the 2. Either way, that's going to equal 1/9. And that's all for Form A, I think, right? Nope, that's a quiz 8.2. I'm not sure where Form B is. All right, here we go, Form B. So we're going to write the number in simplified radical form. Root 9 over 2 is root 9 over root 2. That would be 3 over root 2, so I would need to rationalize the denominator by multiplying by a clever form of 1. That would be root 2 over root 2. In the numerator, I'd get 3 times the square root of 2, and in the denominator, I've got square root of 2 times square root of 2, and it'd just be 2. Okay, so I get 3 root 2 over 2. Number 2, I'm going to have the square root of negative 54, so I need to think to myself, what's a square number that divides 54? And I know 6 times 9 is 54, and 9 is a square number, so I feel like that's going to be a good place for me to start. So this is the square root of 9 times the square root of 6, but this is also negative, so I'm going to include that square root of negative 1. Square root of 9 is 3. I don't have anything for the square root of 6, but square root of negative 1, I have something for that. We call that I. Okay, so I'll have 3 root 6 I. With the next few, we're going to simplify these expressions, and we're going to assume the variables are positive, so we don't have to worry about like any absolute value or anything. We're going to rationalize denominators, and I'm going to also be giving my answer with positive exponents, although that's probably not something you were graded on, at least not if you were in my class. So the cube root of something, okay, I'm going to say that, hey, that's the cube root of negative 27 times the cube root of x to the negative 6. The cube root is the 1/3 power, so it's just going to divide the power of these things by 3. In negative 27, I mean, you could write that as negative 3 to the 3rd and then divide that power by 3 and just say it was negative 3 to the 1st, but that's not really how I've been approaching this. I've just been saying, okay, what's a number that if I cube it, I get negative 27? That's negative 3. And then the cube root of x to the negative 6, that's going to divide the power by 3, so it would be x to the negative 2. And then, I'm going to take that a little farther and write that as negative 3 over x squared, because I know we can do that with a negative exponent. But that, at least in my class, I think I probably gave you credit for either of those two answers. Okay, number 4, square root of 18, that's something we'll have to simplify. Okay, 18 is 9 times 2 though, so I like where that's going. Square root of x to the 6, okay, that'll be half the power, that'll be x to the 3. And the square root of y to the 9. Was this one exactly the same on the other form? I don't know. Maybe it was. No big deal though. So 3 square root of 2 times x to the 3rd, and then y to the 9/2. Don't just leave it as 9/2, right? Yeah, that's fine. If you wanted to call it y to the 4th times the square root of y, you're welcome to do that. All right, number 5. On this one, because I don't know the square root of 20 or x to the 3 or 5 or x to the 7, I'm going to try just combining these first, right? So I could say put the numbers together, then put the x's together. This is multiplication, connecting these so we can multiply in whatever order we like. And then, it starts to get better. This is 100x to the 10, because I'm going to multiply 20 times 5, and then I'm going to add those exponents, because x to the 3 times x to the 7 would be a total of 10 powers of x. And then I can take the square root of 100, that's 10. And I can take the square root of x to the 10, that would divide the power in half, that would be x to the 5. And because x is, guaranteed to be a positive number, I can say I don't really have to worry about that. Actually, that is going to be 10x to the 5 either way. But yeah, we don't have to worry about that because x is a positive number. Okay, with this one, we're going to take the square root of 16 and the square root of x to the 4 first, and then we're going to worry about the rationalizing the denominator after. So this is going to be, square root of 16, square root of x to the 4, divided by square root of 3. And that's what we're going to need to rationalize. So I need to multiply by the square root of 3 down here to get, 3. And then I need to be fair by multiplying by square root of 3 on top, so I'm not changing the fraction by multiplying by something that isn't 1. And then I'll get 4 square root of 3x squared divided by 3. Alright, with the next 3, we're just going to write these as a rational power of 70. So that means we're going to, write an exponential expression. 70 is going to be the base, exponent's going to be a fraction. So this is going to be equal to 70 to the 8 divided by 3, because the index of the radical, that wants to be the denominator of the fraction exponent. Okay, 70 to the 5th square rooted, that'll be 70 to the 5 divided by 2, because the square root is the 1/2 power. And then 70 root 70, we're going to call that 70 to the 3/2, because this 70 is 1, this 70 is half, so together that would be 1.5, and that's 3/2. Then these last two, we're going to just evaluate the expression, which just means I can figure out what it's equal to. So what I'm going to do is I'm going to say 5 to the negative 3/2. That is not right. Hold on just a second. Yeah, that was supposed to be 9 to the negative 3/2. Okay, so that would be 9 to the 3/2 to the negative 1. Okay, so I'm going to deal with the half power first. So that would be the square root of 9 cubed, then taken to the negative first. Okay, so square root of 9 is 3. That's 3 to the 3 to the negative 1. That's 27 to the negative 1, and that is 1/27. And the last one, 8 to the 2/3, we're going to deal with that fraction exponent first, the cube root of 8, and then we're going to take that to the second power. So the cube root of 8 is 2, that's 2 squared, and that's going to be 4. And I think, yeah, that's all for this quiz, so thanks for watching.